Okay, a little fun project for the day. I've picked this up on the Evil Mad Scientist website. They always have a lot of fun and educational science-related projects. The Paris Flyer CarouSol kit. Elegant airship travel cleverly modeled with solar engine technology by Solarbotics. It's solar powered. The propeller really moves the dirigible. Choking hazard. This was, I forget what it was about 30 bucks. Assemble your own Paris Flyer airship. Propeller driven by energy concentrating solar engine. The Flyer silently orbits the docking station. Ages 14 plus, basic soldering and tools are required. Solar powered, no batteries needed, 1 to 2 hours build time. Clear, beginner friendly documentation. Low friction rotation point provides smooth, graceful motion. Precision laser cut wood frame. Dual solar cells generate energy for the solar engine even in room level light. The more light it gets, the more often it activates. In full sunlight, this kit is always moving. Okay, let's pop the box open. We have the printed manual, several pages of it. We have some newsprint for padding, packing. This is mechanical and electronic components. And the stack of laser cut wooden parts. And that's it. Okay, we have a steel ball, which I'm guessing is there for weight. And we have a slightly concave, or convex, depending which side you're looking at, metal dish. And you have this pointy bit of metal that's threaded to receive a screw. I imagine that will sit down in this, and that'll be the low friction balance point. And I think this will be the screw that goes into that. And then we have our little bag of electronic parts. That's including a motor and the solar cells, and looks like a little circuit board, transistor, capacitor, a few other parts. We'll get to that later. I open the plastic bag with the wooden parts, and I get the old smell I remember as a child with my wood burning kit. The kind that looks like a soldering iron, and you burn your initials into pieces of wood and stuff like that, or try to do so-called artwork. Anyway, there are 4 panels here. I don't even know what they are. I assume these were plywood, but from the edges it almost looks like it's... I would think these would have to be plywood, but it almost smells like masonite, so I'm not sure what that's made of. It definitely doesn't look like plywood here. This may be some pressed fiberboard. Anyhow, so I think this is parts of the Eiffel Tower, the base, and then some joining parts, and then I think these are probably parts of the counterbalance assembly. You can see the lines a lot more clearly on this side. And this is probably part of the counterbalance and part of the Eiffel Tower, parts of the Eiffel Tower, I think. This may be part of the dirigible, some little wheels or whatever. And again, I think these are probably parts of the top section of the Eiffel Tower. And these cross pieces, I think it's most likely that these are associated with the solar cell supports. And again, some squarish pieces that probably have something to do with the... This is probably for the Eiffel Tower, since this is non-symmetrical. This may be part of the solar cell support. Again, just guesses. And I think probably all the parts on this one are part of the dirigible. Well, here they say it's ages 12 plus, and the box said, what did it say, 14 plus? No batteries required, solar powered. They appear to be based in the States. The document dates back to 2018, so this kit's been out for a while. There's an introduction. The transatlantic Tesla Tech dirigible Paris Flyer is about to depart for New York City. Please stow your luggage and wait for our attendants to ensure you are strapped in securely. We will be reaching a rotational velocity of 0.628 radians per second and maximum g-force of approximately 4 times natural during the launch cycle. The approach to the transatlantic ion energy channel will take approximately 9 minutes after launch, after which your harness will release and you may explore your cabin. Enjoy the view from our climate-controlled viewing gondola while we approach our maximum cruising altitude of 3,000 meters, or settle in for a meal at our 4-star restaurant. Thank you for flying Tesla Tech Airways. We hope you enjoy your flight. Alternate history playtime fantasies aside, the Paris Flyer is a kit inspired by the whimsy of creative wind-driven mobiles and wonderful autonomy of self-activating solar-powered energy. Unlike other solar-powered devices, our solar engine trademark allows us to extract useful energy from several light levels otherwise unusable by solar cells. In direct sunlight, activation happens in seconds. In an interior fluorescent lighted office every 6 minutes. If there is sufficient light to read by, this device is still working. We hope you enjoy the little story our model tells and have fun with both the mechanical and electrical assembly. As with all Solarbotics kits, we guarantee a successful no-fear build, so do enjoy the process even if you experience a broken or lost part. Contact us and we will set things right. So we've got the parts list, the 4 sheets of wood, the rotation point and screw, the spinning surface, that's the disc, the counterbalance, that's the ball, and the motor and the propeller. Yeah, the propeller is in this bag too, a little black plastic propeller. Some wire, that was this, and then I'll inventory the electronic parts when I get to that. It does say you require wood glue for this. Aha. White glue or wood glue, soldering iron, yes. Solder wire strippers, 30 AWG capable. I usually don't have the patience to use white glue for stuff like this. I'm more inclined to use CA glue. The problem is I think I'm out of CA glue. I may have to make a quick trip to the hardware store. Alright, here are the components for the circuit board. There are 2 solar cells, and they're not just simply solar cells, they're attached to circuit boards. With some writing on it suggesting the attachment of transistors and capacitors and so on. And that's the other side of that. And our little circuit board. 2 electrolytic capacitors, 2 transistors or 3-terminal ICs, the little motor and a diode of some kind, and a double-sided adhesive foam pad. Oh yes, and the propeller, which came out of the same bag. So this one capacitor is 22 microfarads. The other one is much larger. This is 0.22 farads. Huh. Well, the first problem, I was just reading along with the instructions and expecting to find one of these to be a 0.22 farad capacitor, sort of a super cap, and in fact they're both marked 22 microfarads. You know, what is that? That's like 10,000 times difference. And I checked them on my LC bridge, and they are both in fact approximately 22 microfarads, so one of those caps is totally wrong. Kind of hard to imagine they would screw up that badly. I wonder what else they messed up. There's a diode here. I guess I can take it on face value that that's a diode. Doesn't say what kind. And then we have a 2N2222 general purpose NPN transistor, and this guy might be some sort of an IC. Let's see what it is. Yeah, this is in fact an MCP112-195 voltage trigger part. So that's correct. 2 solar panels, got those, the 1 diode, the double-sided foam. They say double-sided sticky tape. That's not what it is. It's a double-sided foam pad. Double-sided sticky tape is a different thing. And otherwise I think everything's good. But I don't even want to start assembling this until I get the right part, because I would just solder a couple things and have to turn everything off and come back whenever they send me the right part. So I think I'll have to concentrate on the woodworking part for the time being. Alright, let's take a look at the circuit. I've just mapped out the simple circuit board and downloaded a data sheet for the IC that's on here. The 2N2222 NPN transistors, the one part that's a 3-lead device, and the other one, the MCP1112-195, is a microchip part intended for controlling the microchip microcontroller ICs that they manufacture, or similar products. And it's designed to disable the operation of those unless the power supply being used for the microcontroller is within a reasonable operational range. Here it's being used a little differently. Here's the schematic. We have a couple of solar cells wired in series. They connect up to the circuit board on the plus and minus terminals associated with the solar cell. Immediately the supercapacitor C1, the 0.22 farad, I'm guessing at 16 volts because at the time I'm doing this part of the video I have not received the actual part from the manufacturer to replace the incorrectly stuffed part they provided with the kit. So I'm guessing it's probably no more than 16 volts. Probably a bit less. Anyway, so that stores energy coming from the solar cells, and at some point its voltage will rise up to a certain level. That voltage is applied to the VDD pin of the MCP1112, and the VSS pin, this is basically the positive power terminal, the VDD. The VSS is the minus side of the power terminal, and it's connected with a diode like this. Oops, I drew it backwards. Okay, here it's drawn correctly with the cathode facing towards the circuit common, or ground if you will. And that just causes a voltage drop across the diode to offset the VSS. So the VSS is not actually sitting at ground. It's, you know, approximately 0.6 volts, 0.63 volts, maybe as high as 0.7 volts above ground. So this point here will be offset from ground by that voltage. And then that voltage is developed across the second capacitor, C2, which is the 22 microfarad 16 volt capacitor. So this IC here, this chip, is monitoring that voltage from here to here, and it's looking to see when it exceeds 1.9 volts. In this case, because of the offset, it's looking to see if VDD to circuit common is 1.9 volts plus the voltage offset. When it is, the output turns on. This is a push-pull stage, so it's connected essentially to VDD whenever VDD is above that 1.9 volt threshold, and whenever VDD is below a 1.9 volt threshold, then Vout turns off. Actually connects to VSS, so it's connected to here or to here, but we can just think of it as being high or low or on or off. So when the Vout is on, meaning there is sufficient voltage developed across this capacitor, and essentially from here to here, then it turns this transistor, the other thing here that's I don't know what it's called on the circuit board. I think it's just identified as the 2222 transistor. Then this acts like a switch and it closes, and that allows the VDD to flow through the motor, back through the transistor, and back to circuit common, and hence back to here. So this is your power switch for the motor, and it's controlled by whether or not enough voltage has been developed from here to here. So in practice, what's going to happen is the solar cells will charge up this super cap. When its voltage gets above a certain threshold, then this device will detect it, will turn on the switch here, allowing the power developed across the super cap or in the super cap to flow through the motor, turning it on, running the propeller, and that'll keep happening until the voltage drops here, and then the detection here will say, oh, it's below that threshold. It will turn off the transistor, which turns off the motor. So if you have a lot of light energy hitting the solar cells, then this stuff basically, isn't doing a whole lot. It's just allowing the motor to run. But if you've got a low light situation where it takes a while for these solar cells to put enough charge into this super cap required to run the motor, then when it finally accumulates that much charge, then it'll run the motor until that charge is depleted, and then it will charge it up again and then run the motor for a while, shut it off, charge up again, and repeat. The IC here has a provision for anti-chatter, which probably doesn't really come into play very much in this situation. Maybe it does. If you look at this curve as being VDD, gradually increasing from 0 volts up to, well, their chip's rated for a maximum of 7 volts. I doubt it gets that high in this particular circuit, but it crosses the 1.9 volt threshold. At that point, it detects that it should be turning the output on, but it actually has some hysteresis. In effect, it waits a little bit before it actually turns the output on. And then whenever VDD starts dropping and crosses that 1.9 volt threshold, instead of shutting the output off right away, the hysteresis keeps it on for a little bit, a short period of time. And that way, if you had VDD just, moving around right around the 1.9 volts, where it's slightly above, it's slightly below, if you didn't have the hysteresis, then the output would be chattering. It'd be like on, off, on, off, on, off, on, off, on, off, really fast, or just kind of clattering or chattering. So the hysteresis forces that to slow down a little bit. In the timing diagram for the IC, it makes it look like it's a fixed time. I sort of wonder if that's what it really is. Hysteresis is usually done in a circuit like this by using different thresholds. So it might use 1.9 volts to turn on, and then, or 1.95 volts to turn on and 1.9 volts to turn off, and that would result in the same thing. But they do show it in the timing diagram as having a time associated with it rather than a voltage. So maybe they actually are doing it with a timer circuit in the IC rather than a slightly different threshold. I can't tell you offhand. Okay, I'm going to proceed to build the Eiffel Tower here. Do that portion. Should come out of this sheet. Normally I'm doing this by two hands, but just for this demonstration, I've got to come up with something a little different. Just show how these pieces punch out real easily. Like that. All of these laser cut parts are kind of a smoky brown on one side and a much lighter color on the other, and I think you can assemble these sort of one's face or the other out and it would go either way. So I'm going to build up just without glue each subsection and then find out which way I like the appearance better. And if there is one section that can't be built with the same side facing out as all the others, then I can reverse the ones that can be reversed to match. So that's the purpose of this exercise. Alright, it does look like I could do it all with the same face out. I just like the slightly more rustic look of it. Anyway, all the edges are going to be dark from the laser cutting, so I thought this would look better and these wouldn't jump out as much against the really light colored opposite side. So all I need to do is glue it up. I did decide that probably I'm going to use the recommended glue, although frankly I'm not sure that I have to. It might be just as good to wick some super glue into this and accelerate it. Well, I did a test of just applying some super glue to the seams after they're together with these three scrap parts and then hitting them with a puff of accelerant. And of course it's fairly strong, but it's all on the surface. It doesn't really necessarily wick into the joints very well, and plus you can see where you did it, whereas I think the white glue will dry very clear and probably fill the gaps a little better. So I'm going to go ahead with the recommended approach and glue. The only thing about this stuff that I don't like is even though it's a little bottle, it's got this ginormous woodworker's glue nozzle on it, which is going to make things messy. Okay, I've got it taken apart, glued, put back together, and the instructions just say to put glue in the low spots when you're assembling it. In other words, the ones that are highlighted. And I did that, and then I also went along major seams, such as around the base plates and so on, and just put a blob of the white glue, dragged it around with a Q-tip, cleaned it up so it would kind of just soak in all along the joint. I think that'll make it stronger. Now for the spinner surface. So we have a wooden ring here, and we have the spinner surface, which is the slightly concave, or convex if you look at the other side, disc. And it instructs to put this down on the table, dome up, and then take the spinner ring and put it down over it and force fit it around the ring by just pushing it against the table. So we have it there concave and convex down inside the ring. And now we glue this down onto the top of the tower, being generous with the glue, as it says. Well, I thought I would move ahead and build the counterbalance bracket and arms, but those require putting in the circuit board and then sort of building around the circuit board. Circuit board isn't built yet or tested because I don't have that one part, and I wouldn't be able to assemble it, I don't think, after I build the wood around it, so I can't do that. And I thought I would build the dirigible, and certainly I could do a little tiny bit of it, and I might, but before you get into it past the first step, you have to attach the balance arm to it and parts associated with the motor, so that's no good. I can only get into it just barely. So I think there's not much point in progressing with that. I have gone back with the tower here and just put a bead of glue around there for extra strength, and then because the legs here don't have a bracket or anything at the bottom like all the other sections do at each end to help hold them together, I ran a bead of CA glue or super glue up inside the legs and hit it with accelerant just for a little more stability in that area. I'll have to do some other project and come back to this. It's been a whole day so far and I have not heard back from the voice message and the email I sent to Solarbotics. When I call in, it just has a message saying whoever, doesn't matter who you're trying to reach, they're always on the phone. I suspect they're not even open. So I think if I don't hear from them by tomorrow, I'll just go ahead and source out some 0.22 microfarad super caps on my own, but I don't know what voltage to make them. I do know that the voltage trigger IC, which, depending on how I edit this video, has already been discussed or will soon be discussed, but the voltage trigger IC on the circuit board, believe it has a maximum of 7 volts input. That makes me think that the solar cells don't generate anywhere near that much, you know, even if they're out in sunlight. So 0.22 farad super caps with a 5 volt rating are very common and inexpensive. Although so far I haven't found any that are in a radial lead package like the manual seems to think they should be. But that may be another mistake, I'm not sure. Anyway, if I don't hear from these guys tomorrow, I'm going to, I think, just source out my own. Okay, to do the test on the solar cells, let's see, yeah, so the actual plus and minus of the solar cell is right here, plus and minus, and there's the other one. And it says to wire them in parallel, plus to plus, minus to minus, and then tap off those. It really just says to wire the output wires to these terminals. The minus goes to minus and the plus goes to plus, so they're really all in parallel. I think you're supposed to mount some capacitors and other components on here in certain applications, optional components, it actually allows mounting some of the same parts really as are on the separate circuit board for this Paris Flyer. It has the NPN transistor, the voltage trigger IC, a couple capacitors, a diode. Looks like all those components can, in some other applications, be soldered to this board instead of to this board. But all I'm going to do is wire them. I actually probably don't even need to wire them in parallel. I think all I need to do is just take one of these outside and hook it up with a voltmeter and see what kind of voltage it generates. Okay, I have one solar cell hooked up to the leads of my digital multimeter. I'm getting about 1.1 volt. I'm going to flip it over so it's exposed to my workbench lamp, and I'm getting about 2.8 volts. So that's just with this big bright LED lamp. Just with the dim room lighting, it's about 1.8 volts. Okay, so out here in a partially sunny day with the sun being behind a cloud at the moment, I'm getting 6.33 volts, or 6.3 volts, and I suspect when the sun gets out a little bit behind the... Of course the clouds are moving the wrong way. It's going to be a while before the sun comes out, but suffice it to say I don't think a 5 volt super cap is going to be adequate. I better plan on it being a bit more. Okay, here are all the frame ribs, 6 of them, and the top and bottom ribs. The top rib is the one with 2 bumps on it, I believe. No, the bottom rib is the one with this stuff on it. That's supposed to be a gondola, I guess. And then the top rib just has a rudder on it. In retrospect, I think it is probably better just to use the white glue on this. It's a little fiddly to get all the ribs snapped into the notches in the frames, and to get it so they're not tipping very much sideways. There's a little misalignment here. But some of that's just due to the warpiness of the thin masonite. But with the CA glue or the super glue in there, when you make a close contact, it tends to bind or bond up pretty quickly. And it can do that while things aren't completely in the right position. So using the white glue would definitely give it more work time and make it a little better in that regard. Well, I've got as far as I can go on all of this until I get the circuit board issue resolved. I have put the railings on the 2 platforms for the Eiffel Tower. That was a step that I had skipped before. Well, just as a contingency in case Evil Mad Scientist or Solarbotics don't send me the desired part, I bought from DigiKey a part that I selected without really knowing all the specifications, but it is a 220 millifarad or 0.22 microfarad part, and it's the correct technology. It's 3.5 volts, which I believe was higher than the maximum voltage I was getting out of the solar cells. I don't even remember now, but it's the highest voltage I could find in a package that was compatible with the circuit board. So here's the part. 3.5 volts, 224, or 224, that's the code for the capacitance. plus and minus marks for polarity. Capacitors of this sort, the round kinds in the supercapacitors, are wrapped, so the layers are wrapped into a cylindrical shape. In a capacitor like this, they're just simply stacked and put inside a little plastic box. So as for fitting the circuit board, the lead spacing of 5 millimeters is correct, and it does not occlude the terminals for the solar cell, nor does it overhang any other components. It does slightly overhang the circuit board on the side, and the end. I don't know if that'll be a problem or not. Okay, I've just done a test setup with the balance base, the two balance base electrical towers, and I haven't put the cross support in it, but the circuit board is sitting down in its designated place, and it doesn't look like the capacitor being slightly wider on an overhang or hanging over slightly there is going to hit anything. The sloped surfaces here are for the solar cells, and the capacitor does not come out far enough or high enough to hit anything there, so I think that this is a good enough reason to go ahead and solder this circuit board up using this substitute part. Just double checking my capacitor to make sure it is a 22 microfarad for the other one. Okay, there's the assembled circuit board with all 5 components on it. Got the super cap overhanging slightly as expected, and the regular 22 microfarad cap, the 1N914 diode, and the voltage threshold IC, and the 2N2222 transistor. The instructions say to cut 4 pieces of wire 8 centimeters long each, 2 of each color. So there's brown and red provided, at least with my particular kit. I gather that maybe they use different colors from time to time with different kits. And you're supposed to strip roughly 2 millimeters of insulation from each one. The brown ones here are actually wire wrap wire, so I was able to successfully use my wire wrap wire stripper. But the red wires are actually stranded wire, and they're a slightly larger gauge, and they wouldn't strip using that tool. But luckily I had this other stripper, and I was using the smallest size, which is designed for 30 gauge wire, and that worked fine. I don't know if that red wire is 30 gauge, but at least it's close enough that the 30 gauge stripper aperture was suitable. Using 2 of the wires, a red one and a brown one, I've connected the plus to plus and minus to minus on the 2 solar cells. And the remaining 2 wires, a brown and a red, soldered up to the solar terminals on the circuit board. Red in the plus, brown in the minus. And then those 2 wires are soldered up to the plus and minus pads here, which are electrically common. So it's really just like wiring the 2 solar cells in parallel with the solar terminals on the circuit board. And then the small DC motor, the remaining length of wire, which is fairly long, red goes to red, and whatever other color remains goes to the blue. And then Those get soldered to the motor terminals of the circuit board, red to that position, and essentially the extended blue wire going to the other position. They do stipulate that polarity in order to get it to fly in the correct direction. And I've temporarily pressed the propeller onto the motor shaft just a little bit. It's important to get that nub where it extends out more from the propeller. You might even call it the propeller spinner. Needs to be on the side away from the motor. And airflow should go in that direction, away from the motor. So it says to place these, it says under an incandescent light, and wait 2 to 8 minutes, holding the motor so the propeller can spin freely. When it activates, you should feel it push air away from the motor. If not, reverse the motor leads. If you haven't seen any action after 10 minutes, consult the troubleshooting section. So I have the two solar cells, the circuit board and the motor, with the motor taped up to a cardboard box. I'm out on the driveway in the sun, and I've got it shaded with my hand, so I'm going to remove that, and the motor runs. It almost stops periodically, and then it runs again for a bit. Sometimes it almost stops and then resumes. Sometimes it waits a few seconds before it runs. So that's I don't actually feel any breeze blown from this, but I don't think that prop spinning at that speed is going to really generate a whole lot. Anyway, it seems to be working. Alright, I'm now mounting the circuit board to the balance base, as it's called, with half of the supplied double-sided adhesive foam. This is kind of like old, worn-out foam that's barely sticky. That's not a very good sign. It's like old crap foam. Like that. And then they want you to orient the wires to go out the proper way. Like that. So the two towers and the support bar are glued together, and I need to put those down on here now. So like that. Well, I had some 3M VHB double-sided foam that was much newer and with better adhesive, so I've cut the strips and stuck them on the edge of the X-frames, or the towers as the instructions call them. Okay, the solar cells are now stuck into place. Circuit board's down inside of there, almost invisible. I just have these couple of wires, the ones that interconnect the two solar cells, sitting up above. The other wiring is tucked inside there. Next up, I take this weight, which feels too light for steel. I'm not sure what's inside of there. This could be any number of things with just a plating over it. It almost feels like the weight of aluminum, but with a steel coating on it. Not sure. Anyway, those get sandwiched between the sides of these two balance holders, as they're called, like that. And then these other parts sort of snap onto the the balance base here. Trying to get that to slide on there was a real bugger. The instructions just make it sound simple, like just slide it on there. But there's a lot of pieces that have to interlock, and there's a lot of friction and not much of a place to grab. But I finally was able to wiggle it on there over about 10 minutes. It definitely grabs the balance ball there firmly, and it doesn't need any glue. And now we have to put the railings on the power base, or whatever that's called, the base of the power station. Okay, now the decorative railings have been glued on around the power base. And then the 8 isolators, or insulators, supposed to look like old school electrical insulators, I think, in line with it being the power station. Next, I attach the balance arm to the power station, and it just slots in between those two pieces so that the rectangular cutout lines up with this. Actually, it needs to go the other way, like this. And then this rectangular mounting pin tab jams through the slot and holds everything together. Okay, that mounting pin tab has been pushed in there. It was quite difficult to do. I tried to squeeze it with the pliers and it wouldn't go through, and it was starting to mash out at one end. So I just stopped there, pulled it back out, and sanded it a bit until it went through firmly, but you know, you can see where it's a little bit smaller than the hole on that end. But it wedged in there pretty nice, so I'm pretty sure it'll do the trick. Now I've removed the balance arm from the power station, and following the instructions, I've added it to the Zeppelin in this manner. There's a mounting peg, that's the piece that's going horizontally there. It goes from one of the frame ribs through the hole in the mounting frame and through a little donut there, that's the mounting ring, and then through another hole in the next forward ring, or frame ring. And I'm supposed to glue the donut there to the frame ring, but not glue the balance arm. And I think that's to allow it to be positioned a little bit forward or backwards. Maybe for best balance. I removed the balance arm, as I said just a moment ago, because the instructions show the balance arm being attached to the power station and then being hooked up here, but this is such a fiddly connection to get that mounting peg to go through there. I thought it'd be a lot easier to do without all this junk stuck to it, and then I can go back and reattach the balance arm up to here to the power station boom. Okay, so now I've reattached it, and now I have to fish the wires around. And then the motor's fed through in front of this frame rib and through this one, and then the motor is just pressure fit into the rear frame rib, and now the propeller has to go on. And then the propeller's on and the motor's pushed back in until there's just a little bit of clearance between the propeller and the rear of the airship frame. Okay, the wires have been routed through these little clips along the balance arm, and with some slack down here. It still might be necessary from time to time to take the balance arm in half from the power station, so I think having a little slack there is good. However, the wires are just supposed to snap into these little cradles, and I found that they did not. They don't just go in easily, and then when you push them in, then they seem to pop right back out. I did not find that they grabbed the wire adequately. I don't know, perhaps the kit manufacturer changed the gauge of wire slightly, or if it's just not that good of a plan. But, oh, the other thing is you need to have enough slack with the wiring within the dirigible model, or the airship model, to allow the arm to go all the way to the front. So there has to be enough slack in the wire that you can do that. But then if you move the arm back, or the airship forward, there would be even more slack. Now, nothing in the instructions says to insulate these wires where they're soldered to the motor, so I'm leaving them accessible, and that might be handy if you decide that you got it backwards after all. So I'm just spreading them apart so they don't touch each other. Okay, the last step, and I did this out of sequence just because I thought it'd be too easy to lose this part, is the little flathead screw and the balance point, or the rotation point. Oops. Those go into this slot down under here. The screw head goes on the top, the screw goes through the slot, and then, or through the gap, and then the rotation point goes on the bottom. Alright, there's the rotation point, centered in there and fairly snug. Okay, I'm on here now and I have to do the balancing. Obviously it's too heavy on the power station side, but it is spinning around very easily. This adjustment there is to get the airship to tip that way or that way. And it needs to have a little bit more to the front. I can't slide it quite enough. And then a little bit of weight needs to be added out here to get it to balance more or less levelly. It's not a lot of weight, but it's a little bit. I'm surprised they say that if it doesn't balance, you probably forgot some of the cutouts that are still present, but I've looked it over. I don't see any that are missing on either side. So the only other solution is just to add more wood to the side that's lighter until it does balance. Well, I've super glued four 440 nuts right near the nose and on the bottom of the ribs. Well, it's better now, but it's not quite right yet. Okay, by sliding the balance point there, I've got it to be slightly nose down. There, I've got it horizontal that way. And it probably needs one more nut to make it horizontal. Okay, I've got the Zeppelin more or less level now. I've got the balance arm pretty much horizontal, and the Zeppelin hanging nose to front level, and the weights I put on the bottom aren't all that noticeable. Alright, I think that's good. Okay, I've picked a spot on my driveway that's getting sun yet. And there goes the propeller. It stopped. The propeller's running again. Propeller's running again. And stops. Running again. And stops. since it balances so well, obviously it's gonna keep going at a pretty good rotational speed, even with just a little bit of sun coming in low. So it's working well. Doing what it's supposed to be doing. Whenever it accumulates enough energy from the sun via the solar cells, it runs the motor just enough to give it a little push and then backs off. Here's a place where it's getting less direct light, and it's getting hit by some wind now. Now the propeller's running, and it pushes it around a bit. And it crawls to a stop. Almost a stop. Waiting for it to pick up some energy, get a charge. Now the wind's blowing it backwards. So far the motor has not run in this location. It's not really quite in direct sunlight. Oh, there it goes finally. Gets a little puff going forward and then runs out of steam. But it does work even in that light. If I didn't have the wind slowing it down, it would probably coast around better. I relocated it to my basement, and it's been sitting under the rather distantly spaced LED lamps for about 10 minutes, and it hasn't run so far. So for whatever reason, the LEDs just aren't doing it, although the instructions say that it should run okay from fluorescent lights overhead in an office environment. For example, if the rig was put up on top of a file cabinet or something like that, that it would get enough to puff it around from time to time, even under that relatively weak light compared to direct sunlight. But I'm going to see if I can run it under incandescence here. I don't have a lot of incandescent bulbs around, but I have this work light that I hauled in from my garage. Let's see if that makes any difference. It was right on the minute that I turned it on, so let's see how well it does. There we go. It took about a minute and the motor only ran for a few seconds, but it did get powered from that, and presumably the charge had to be brought up from a pretty low level the first time since it had been sitting there. It might be a little higher now. Maybe it just needs to be topped off. Got about half a minute since it last ran. Should be coming up on another run if the first one was any indication. Now it's been another minute. Well, it's been 2 minutes since it last ran. That's not encouraging. Well, I'm getting impatient. Let's goose this thing with a little more direct light. Okay, now I've got the light a lot closer and the motor ran almost right away. Of course, it had probably been soaking up charge. Oh, the motor just ran again. Goosed it ahead a little bit. I don't know, it helps if I put it overhead. There's running again. Gave it a little kick in the pants. So I'd say it's working pretty well, but it definitely works best in direct sunlight. If you can get it near a window with the sun coming in, I think it'd probably work best. Or if you can arrange to have an incandescent bulb, like 100 watt, like this one is, fairly close overhead, it'll probably have just enough to keep it going, albeit rather slowly. I don't have much faith in it working off fluorescence, but I have no fluorescence to try it with. And it certainly didn't run worth a darn with the LED lighting I have in my basement. It might have got there eventually. It might have been a very slow accumulation of charge. It might have, but I don't think it would have coasted long enough to wait for the next charge. Now it just ran again. I'm trying it on my workbench under my LED work light, pretty close to the solar cells, and I'm going to time it and see how long it might take. Well, it's about 8 minutes since I left, and I came back to find that it had moved. So apparently at some point, I just walked past the room and looked in about at the 6-minute point, so somewhere between 6 and 8 minutes of operation under this light, it did move. I think probably only once. So we'll check and see if it moves again. And there it kicks on. Just ran for 2 or 3 seconds, but was able to give it a kickstart. And we're now, what is it, 16 minutes after I first put it under the lamp, and it's run twice, so 8 minutes under this work light or bench light to get enough charge to run it for a few seconds. So it's definitely not going to keep spinning in the interim, but it will move from time to time. So I've answered the question, will it run under LED lights? And the answer is yes, but don't expect it to run very well. And I really had the light close to it and aimed right at the solar cells and everything to get even that to happen.